Good afternoon. Today, you and I are going to talk about Chapter 10, Lesson 4, Space Figures. Now, some of these are really hard to visualize, which is why I'm going to have you guys do a small project where you get to make some nets and some space figures so that you can kind of start figuring out what they look like. And I will definitely go over some of this in class when you actually have to do the lesson, because this is a little convoluted. This is something that's a little hard to visualize, because it is hard to visualize a 3D object on a 2D space. A 2D space would be like the screen of your iPad or your piece of paper. So again, I'll have you look at some examples a little bit later. But until then, let's talk about space figures. Space figures are three-dimensional figures, also called solids. Space figures we will study in this chapter are prisms, which later on in math you will start calling cylinders, and I will talk about the difference in just a second. Pyramids, cones, and spheres. So prisms are also called cylinders because they're basically in like an elongated shape. It's like taking it's kind of hard to explain, again, because you're listening to me and not able to see me. But basically, whatever a prism is also a cylinder. Now, whenever your book refers to a cylinder, it's going to be referring to a circular shape that's elongated. And when it talks about prism, it's going to talk about a polygon shape that's elongated. But later on in math, they kind of mean the same thing. It's just basically any shape that's elongated is a cylinder. But specifically in your book, a prism is a polygon or rigid straight-shaped object that's elongated, and a cylinder is a circle that's elongated. Okay, so a prism has two parallel bases that are congruent polygons and lateral faces that are parallelograms, and a diagonal connects the two. So here it is. So here we have two faces. This one right here, in this case, this face is a hexagon because it has 6 sides. All right, so those are the bases. And they are congruent, they're the same shape and size, and basically they kind of look like they've been pulled apart from each other, and that's what gives us the lateral faces and the lateral edges. Now, lateral faces are faces that are polygons, and in this case they're actually parallelograms, and they're usually straight rectangles. So there's a lateral face, here's a lateral face, there's a lateral face right here that's in the background, that's behind that shape, and if this was truly a solid, you'd be able to see it. And maybe I should start using just different colors. And there's another lateral face that's also in the background right here, that's also a parallelogram. And then there's another one that's right here that's also in the background. And then one in the foreground that's closer to you is this green one. It's just going to make things look a little sickly. There you go. And then we've got a blue one. That's right there. And I'll make this one purple. Okay, so all of those are the parallelograms that make up the sides of this elongated hexagon. All right, so there you go. And each of those that I just drew, actually, let me bring that back, has a lateral edge. And the lateral edge is where each lateral face touches the next lateral face. And lateral faces that are in the, lateral edges that are in the background tend to be dashed. Okay? Lateral faces that are in the foreground tend to be a solid line. Okay? So you see it? So again, a lateral edge is going to connect that green side and that blue side together. And then there's another lateral edge that connects the blue side and the purple side. And the same with the purple side and the yellow side and the orange side and the orange side and the red side, and then the red side and that green side. Okay? So definitely think about these in three-dimensional ways. All right, and then the diagonal, which is going to be really hard to see, so I'm going to do it in a dark color, just connects one vertex to another vertex on opposite sides. So it goes basically through the center. If you're like to jab your pencil through at an angle and have it come out the other side, that would be like a diagonal. Okay? All right. So let's go ahead and let's see here. I know I've got something else here. There we go. And then a vertex. A vertex usually connects 3 or more lines to a point. And so this one obviously has 3 or more points, and that's the vertex. And then a pyramid. So a pyramid has a base that is a polygon, all right? And you can have a triangular pyramid. So this could be any shape. So this would be a hexagonal pyramid because the bottom part is a hexagon and then the lateral faces are made up of triangles. So if I were to go through and do this, I've got a lateral face right here. I've got a lateral face in the background, which is this triangle right here, which again, they're going to be overlapping, so it's going to be really hard to see. And then we've got a lateral face right here that's also a triangle. And one that's, let's do another one that's right here. And then we have another one that's right here in the foreground. And then we have another one that's here. Okay. So again, it's really hard to see. And all of these lateral faces are connected by lateral edges. All right, and again, lateral edges in the background are the dashed ones, and lateral edges on the front are the solid ones. And then you should also know how many lateral faces there are based on the base of the figure. So if the base has 6 sides, there should be 6 lateral faces. It's the same with the prism and the same with the pyramid. Okay, so there you go. All right, let's move on to the next one. Oh, also a K-cylinder. All right, so now, this is really what your book calls a cylinder. It's kind of like a soda can. It's 2 circles that are the same size and they have been pulled away from each other. So whenever your book refers to a cylinder, think of like a Coke can, and whenever they say prism, think of a polygon that has been pulled away from each other and elongated. But when you get further along in math, cylinder is going to mean prism. A cylinder that has a circular base is just a circular prism, and then a polygonal cylinder is just a cylinder or prism that has a polygonal shape. Okay, and we can talk about more of that in class if this is getting confusing. All right, so a cylinder has 2 bases, and in your book, these 2 bases are circles, and it has 1 lateral face. Now, its 1 lateral face is actually a rectangle. So if I were to take this shape and flatten it out, I'm going to have a circle on top, a circle on a bottom, and the lateral face is actually going to be a rectangle where the length here is the same as the circumference of the circle, and the height is going to be how tall it is from between the 2 bases, the distance between the 2 bases. All right, and that's actually what we call a net. And I'm getting a little ahead of myself by showing it to you, so let me get rid of that. Let me get bigger. Okay. There we go. Okay, so that is a cylinder and how your book describes a cylinder, which is 2 circles that are elongated. A cone, I'm sure you guys all know what a cone is, like an ice cream cone. The only thing is it has a flat bottom that has a base, and it's got a solid base to it. It's not like open like a regular cone that you would put ice cream in, okay? And so the lateral face all kind of curve up to one point, and that would be like the cone itself. Like I could even draw a little bit of ice cream in there. Ice cream, but it's an upside down cone. Okay, all right. So a cone has 1 circular base and 1 vertex where it all comes to 1 point. And you're like, but Miss DH, it looks like it only has 2 points. Well, you have to remember a circle has a cajillion of points, and so they all have these lines coming up to it. So it's actually way more than 2 for this one. It only appears to have 2 because that's the way it's drawn, and they don't want to confuse you. Okay? Alrighty. A sphere. A sphere is a set of points, set of all points in a surface, in a space that, let me start over. A sphere is the set of all points in a space that are a given distance from a given point called the center. So all of these points, so there's a point here, that's the same distance from R, the same distance from the point R, and those are all the same distance. So basically all of these points are an R distance. And what is R again? Well, you should know R is the radius. So they are all R radius distances from a single center point. Okay, So let's go ahead and talk about naming space figures. And I got a little far ahead of myself, actually. Okay, so to name space figures, we look at the base shape. Then we look at the elongation of the shape. Is it a cone? Is it a cylinder because it has a circular base? Is it a prism because it has a polygonal base? Is it a, what are the other ones we talked about? Pyramid. Okay, so those are things we need to look out for. So let's go ahead and look at this first one. And let's see here. So we've got two triangular bases. All right, those are the two triangular bases. So that means we've got a triangle going on, right? Two triangular bases. Now let's look at the lateral faces. Lateral faces are all three polygons. All right, so we have three polygon sides. And actually, they're not even just polygons, they're parallelograms, which means we're dealing with a prism. And if you want to call it a cylinder, I won't blame you. I will still give you credit. So triangular prism or triangular cylinder. Now let's look at the next one. This one we have two bases again, but they are trapezoidal. Okay, and then we have several polygonal, also known as parallelogram sides, which means we're dealing with a trapezoidal prism. So definitely make sure you're naming those bases correctly because that will come in real handy. So now let's go ahead and talk about nets. A net is a pattern that you can fold into a space figure, or you can fold a space figure into a net. Basically, if you were to like peel the lateral faces away from the bases so that they're still connected to each other but not completely, like you might have a side that used to be connected to another side that isn't anymore, and it's basically just laying flat. It's like if you were to cut some of the edges of a cereal box so that it lays completely flat, but so that all of the sides are still connected to another side. That would be a net. And a lot of you guys who have had me before have made nets before. All right? So think about all of the shapes that make up the space figure and how they touch. Then draw the shapes as they are connected. So for this prism, or excuse me, this isn't a prism, this is a pyramid. This is a square pyramid, which means the base is a square and then it's made up of 4 triangular lateral faces. And I know it's 4 because my base has only 4 sides. So I'm going to draw the base, and then I'm going to draw the lateral faces. Well, since all the lateral faces are triangles, and they're kind of isosceles triangles, you can take a look at that. Oh, I meant to use black. There we go. So all of those sides are congruent. So that means all of these sides should be congruent as well. And if you think about it, I should be able to fold up each side. So if I fold up, like this side and this side so that they touch, and then fold up this side so it touches and this side so it touches, I will end up back with that shape. All right? It's basically taking a two-dimensional shape and folding it so that I create a space figure. All right, let's look at the next one. Here I have a triangular prism, also known as a triangular cylinder, because it's a triangle that's been elongated, and I need to look at it. Well, this one has 2 triangles and 3 parallelograms. So and the 3 parallelograms all touch each other and then have triangles on the edge. So there we go. So there's one of them, and then the 2 triangles, and then the 2 other parallelograms. So this is the net of this figure. Not as exciting as that one, huh? Especially without the colors. All right, guys. Again, this is something that might be a little hard for you guys to visualize, but I definitely want you guys to try, and we will talk more about this in class. All right, bye.